This is where I want it to go. Alrighty. So basically, as we know, right? So Llama Index is basically just a library for assisting us with a RAG pipeline, right? And you can see it just follows exactly the same pattern that we did without Llama Index, right? Which is essentially, we pull in this data, we then index it. The index is, you can think of this for now as the storage, where our data is going to be parsed, right? Meaning it's going to be split up into, if we have a PDF, then we're going to split this PDF into separate paragraphs. And then each one of those paragraphs can be stored in the database. Each of those records in the database are also vectorized, right? Meaning that they're or embedded, right? Meaning that they're turned into basically like a NumPy array, where those paragraphs are translated into like a list of numbers, right? And that's how we represent them. Then, so we take our data, we embed it, store it into the database. Then a user comes in, they ask a question. That query then gets turned into a vector itself, right? An embedding. Based on that embedding, we calculate the distance between this vector and all the other vectors, find the most similar one, take the relevant documents or the relevant chunks, right, like paragraphs, and feed them to the LLM. So this way, if we have a report about, like the state of the economy, right, and there's things about like jobs, and then there are also things about, finance, and someone asks like, how's the labor market, right? It'll retrieve just the information about the labor market, and that's what will be fed to the LLM, and then the LLM can essentially answer the question provided that context, right? So you're giving a context to the LLM that helps it to answer questions. Right, that's the idea. And why do you want to do something like that as opposed to just use like ChatGPT as it is? Well, because like the information is not necessarily up to date. You may have private information. You may want to validate that information, right? To make sure that is accurate. Cool. So then, how do we use, and then, it talks about like what Llama Index is good for. And we're on this stage essentially, which is loading our data. And with loading our data, there's two different components that we said we really care about. One of them is tokens. Like that's the most atomic unit, where basically each word is translated into a separate token. Okay, it's a little bit like I said, there's probably like slightly more tokens than words, right? Each word is like 3/4. It is a little bit more than a token typically. But like more or less you can think of as token corresponds to each word plus some punctuation. And then really what we'll do, with Llama Index is chunk our text. So here you can see I'm just splitting by sentence and dividing up a document into various chunks that way. But with Llama Index, it can be a little fancier where, let's get to it. You just moved my code. Here? No. I will do it here. Where with Llama Index, we can use like a parser. And basically this is where we can start using some of the tools. So with Llama Index, we take the document, right, that's read in, and then we'll use this parser to translate it into paragraphs. And now we can start, I guess, going through and see, just review this library. So I'm going to run this code. And we can start looking at it. So just remember, what we do is we have this, this is like some World Bank report that we're reading from here. And it's just a PDF. And then this fits library, right? This actually comes from PyMu PDF. So this is a PDF reader. And then what we're doing here is we're iterating through each page in the document, right, that we're reading, and then getting the text, and then just essentially generating a gigantic string of all the words in our PDF. From here, now we're getting into Llama Index, right? We create a document object, right, which comes from Llama Index, and we just pass through the text. Then, right, so this is the entire PDF. Then at that point, we define this parser, which says how should we split up the text. And the sentence splitter means, hey, like split it up into, split it up, what's the word? I always forget this word, into tokens of like 1024, right? But try not to split sentences midstream, right? Like preserve sentences, you know? So the idea is this is essentially going to give you like a paragraph at a time. So here we define the parser, and then we do parser.getNodes from documents. And this is like the first, like if you kind of understand like a document and that a document has many nodes, right, which are those chunks, that's the main thing. Because as we saw, you know, here's our list of nodes, and we can select one of them, right? So that comes from this line right here. We're parsing up our document. Say like here's my first node. And you can see, right, this makes sense. So this is looking like the table of contents, essentially. And you can see that with the node, not only is there the text, but each node has an ID. You can see that there's, we can store metadata about the node, like if we want to store the page number that it came from, we can do something like that. You can also get the earlier node and the later node, right, in the document, which would help you with, say, like getting a summary, like if we want to add in like a summary of the previous paragraph to give more context about this current paragraph, like that helps. And on this node, not only is there the text, right, which we can get with like get content, right, but then there's also the embedding. Right now, I guess we did not store it yet. I'm actually a little surprised. So let's see. So what should happen is that when we index this, I'm pretty sure this would occur. When we index this, when we pass our nodes into this vector store index, it will, not only will it store this in a database, but it will also embed, call the API, call the OpenAI API to get the corresponding embeddings from our nodes. All right. I wonder if it could just be that. Let's take a look. Here's my nodes. Here's my vector store index. Let's take a look at this for a second. Right. So this is, you know, this is both like how we're storing the nodes, meaning in this case we're just storing it one by one after the other. And when someone asks a question, then it will compute, you know, figure out what is the similarity between this question and all of the nodes in the database, right? And then send them back to ChatGPT to basically answer the question about, you know, what is creative destruction in this case. You can start to see where the nodes are stored if you do index.docstore, okay? And then this has, I think it's .docs, okay? And here you can see these are all of our nodes. And I'm guessing these have this like key value pair, I believe. Let's see, .keys, I think. Yeah, so here you can see, right, each one of these nodes has an ID, and then you can like retrieve this from the database. Okay, so this is the node stored in the database. So you can start to see how these things are related. What we did was we took our nodes, we indexed them. This not only creates like the mechanism for how to store these things, but then also is the storage itself, also is like the database. Then we can, from this index, also create what's called like a query engine, and this allows us to ask questions that are then submitted to the database and then retrieved. Let's see if this works. I think it must have. From here, we can call this response. Okay. Now let's look at it. And you can see the response, this also gives us back like this response object. Here it has the text, right? That would help us. And then the other thing that we have are the source nodes, right? So when we ask a question, like what is creative destruction according to the document, we can get the response, response.response. Creative destruction as described in the document, described, is this. We can also get the source nodes that are being referenced, right? So you can see this is the original paragraph, right? That you can see. And it kind of looks like it. Creative destruction is required to allow newcomers, whatever. And you can start to see, right, things that look like they're from the World Bank report. So that, and look at this. This is kind of interesting too, right? This is the score. What is this for, right? Remember that what's going to occur is that we're generating, a similarity score between the question and then each one of the chunks. That's probably what this score represents. And that, based on the score, those are the chunks that are going to be returned, right? And fed to OpenAI. And then OpenAI can use these chunks to answer the question. Okay. So you can start to see why something like this is useful. It allows us to, just in a few lines of code, build a RAG pipeline. How does this feel? Okay.
Jeff, is there any memory storage, or do you have to keep feeding it a context every time?
Well, so when you do this vector store index, this is storing this is storing the data in memory. So these nodes are stored. What you can do is when you ask a question, it has to go into this memory store and recalculate. Basically turn this into a vector, and then go through each one of the vectors in your memory store and calculate the score to find the most relevant documents. Does that make sense? If you want, what you may be asking is, can we save this to disk? That you can do too. That way, and what that will do is, so we can just save this as a file on our computer, our database, and actually the lab has you do that. And what that will do is mean that you don't have to every time you run this, reprocess all the nodes, get the embeddings of each one of them. You'll just do that one time, and then you'll, retrieve load up the database and simply query it. Right? So there's two steps. All of this right here, right? Reading the PDF, creating the document, parsing the nodes. This is all to, create the database, right? As you get more information, right, you'll have to add nodes, insert additional nodes into the database. But you can basically think of that's your ETL process. Then the second step is querying the database. When we query the database, what has to occur? One, we have to vectorize this. Two, we need to compare the vector to each of the nodes. Embedded docs, or I should say chunks in the database. Three, return the most relevant ones. Chunks, and then finally feed those chunks. This becomes our context right here. So we then feed the context to the LLM and say, basically, answer this question based on the chunks, the paragraphs that we retrieved from the database. All right. Cool. Other questions about this? Okay. Yeah, one thing that's, nice that we'll see is like, Llama Index will allow us to, if we want to use a different LLM than like ChatGPT, right, than OpenAI, we can switch that out, and yet, a lot of this stays the same. If we want to use a different vector database than the one that it gives us out of the box, we can do that, and like a lot of the code stays the same, right? So like you can you can change things pretty easily, and yet, keep a lot of your code consistent with doing that, right? It's a really nice interface for building a RAG pipeline. Okay, so the database. Oh, hold on. So Scobie's saying the database we create is used to define the context, and you specify this context in the prompt. Well, yeah, it's used when I wouldn't say define the context. The database is storing each one of our nodes. You retrieve the most relevant ones. That's the most relevant chunks. Those are your contexts, right? That's basically like paragraphs of data that are then fed to the LLM. Yeah. Cool. Other questions about this? Okay, cool. So we have a lab, obviously, to work through this. Let me see. So that would be this lab. The next thing, I can deploy this reading too. The next thing on the list is basically like these data loaders. And these are pretty useful because you can see like, you can use, instead of, using this library, this PyMu index, you can use like the simple data reader and just say like, hey, read everything from this folder. So that'd be this. That's a PDF file. And this reader, then you call reader dot, I think it's load data. And what do you think this would return? This returns a list of documents, right? And now we just pass these documents into my parser, right? And then we store it. So it's like all of a sudden now the next lesson is pulling data, whether it's like reading an entire directory of data, specifying the extension, just look for PDF documents, or maybe it's going to be like pull data from this web page and again create documents out of a document for each web page that we specify. Or as we'll see, like Llama Index also has for like specify this list of Google Docs, and as long as there's the right permissions, it can read them, turn them into documents, and then we can quickly turn them into nodes, right? So this, right, you can start to see how it's like useful to use a library that really, where all the pieces play nicely with one another. All right, cool. So I'll stop from there. I think the biggest thing is for you all to start playing around with this.